Hello students, you are watching MathOLearn. We are studying for class 9 ICSE trigonometric ratios. What are the trigonometric ratios? We have studied in the part 1 sine, cos, tan, cot, sec, cosec. These ratios we are well aware. Now from question number 3 we'll continue and we'll take a more deep in the chapter. Let's see the question number 3. This is the figure it is given, and you have been asked to find the values of cos A, cosec A, tan square A minus sec square A, and this we will see one by one. In ABC, BC is given 12 units. B, this is perpendicular, but level is not given, so let's level it with D. And AD, this portion is only 3 units. You have been asked cos A. You have to identify the cos A and this A, part of which right angle triangle. See, if we take this separately, A, B, D, then this is the right angle triangle, and BD is 4 and AD is 3. So when we have been asked the cos A, that means cos A equal to base upon hypotenuse, and here hypotenuse is AB, which you have to find out. So let's first find out the AB by Pythagoras theorem. AB square equal to AD square plus BD square, which gives 3 square plus 4 square, 9 plus 16, 25. So AB is 5. So cos A, this is the solution of first. Cos A equal to AD by AB, because you know cos is the base upon hypotenuse, and base is what? Base is the side along the angle. So you are talking about angle A, so along the angle AD is the side, so AD upon AB. AD is 3, so 3 by 5 is cos A. This is the answer. Second one. Now cosec A. Now you understand, if you forgot the cosec A, the ratio of the sides, then you might have remembered that sine A equal to perpendicular by hypotenuse, and cosec is just reciprocal of sine. So this is hypotenuse by perpendicular. So for A, BD is the perpendicular and AB is always the hypotenuse. So cosec A equal to 5, because this you have found, this is 5, so 5 by 4. Let's look into number 3. Tan square A. Tan square A means, okay, let's write tan square A minus sec square A. Tan means perpendicular upon hypotenuse, perpendicular upon base. That means BD square by AD square. BD square by AD square minus sec square A. Sec means hypotenuse by base. hypotenuse by base. So AB square by AD square. BD is 4, that means 4 square 16, and AD square is 3 is 9, AB 5 is 25, and 9. So is 9, 16 minus 25, which gives minus 9 upon 9 equal to minus 1. So tan square A minus sec square A, here we found minus 1. Number 4, sin C. Now your angle is changed. Angle is changed, so your triangle is also changed. Now you have to take this BDC. Now for angle C, since you don't have this right angle triangle will not work for you for angle C, so you have to take the triangle BDC. Let us draw BDC. BDC. BC is 12, BD is 4. So again you have to find out DC square equal to BC square minus BD square. That means 12 whole square 144 minus 4 square 16. 144 minus 16. 8, 128. 128. So 128, you probably this is not the whole square number, so this is equal to under root 128 you can keep. So sin C, this angle equal to BD upon BC. That means 4 by 12. So in simplest way, 1 by 3. Number 5. Sec C equal to, sec is, again the angle is C. So BC by base DC. BC by DC. BC by DC, because DC is the base and BC is the hypotenuse. So BC, you know 12, and DC is root 128. 128, if you can simplify 128, okay, 128 you can write root 128, you can write 2 into 64, and 64 root 64, you know 8 is a 64, so it comes 8 root 2. So here root 128, in simplest way we can write 8 root 2. So 8 you can see 4 3s are and 4 2s are. That means sec C equal to 3 by 2 root 2 is the best answer. Let's do the last one. Number 6, cot square c minus 1 by sin square c. 1 by sin square c you can write, or you can write, the sine is reciprocal of cosec, so you can write cosec square c as well. You can do by this also, because 1 by sin c equal to cosec c, so 1 by sin square c equal to cosec square c. Now cot c will be base upon perpendicular. That means dc square by bd square minus cosec hypotenuse square by perpendicular square. So again you can see dc is, we'll write 8 root 2 whole square by bd 4 square 16 minus bc is 12 square by 16, which will give 8 is 64 into 2 128 minus 144 by 16. It will come in minus 144 minus 128 16 minus 16 by 16 equal to minus 1. This is the figure given in number 4, and the first you have been asked sin B. Sin B is this angle, and now you know the BD is given 5, AB is given 13, but AD, the perpendicular which is required for sine, it is not given. Sin B will be perpendicular AD by AB. So for AD, you have to take the help of Pythagoras theorem. AD square equal to AB square minus BD square, and BD is 5. So 169 minus 25, which comes 144, and AD you got 12. So AD you got 12. So sin B equal to AD 12 by 13. Second, sin C, tan C. You have to find tan C. Tan C equal to tan C in this triangle ADC. AD by DC. AD is given, you have found out AD 12, and DC is given 16. So you simplify, 4 3s are 4 4s are. Tan C equal to 3 by 4. That is the tan C. Number 3, sec square B minus tan square B. This is this angle. Sec square B is, sec is hypotenuse by base. That means 13 square by base, that means BD square, 5 square, minus tan square B. Tan square B is perpendicular by base. So 12 square by 5 square, which is 169 minus 144 by 25. So 25 upon 25 equal to 1. Number 4, sin square c plus cos square c. You have to see this triangle ADC. Always you have to take the right triangle. So ADC is our required triangle, and sin C will be 12 by AC. But AC is not given. AC you have to find out. Again AC you can find out. AC square equal to AD square plus DC square. So AD is 12 square, 144 plus 16 square, 16 into 16, 256. 256. 400. That means AC equal to 20. AC equal to 20. This you can write down, AC equal to 20. So sin square C means AD square by AC square. That means 12 square by 20 square plus cos C again, base by hypotenuse. So 16 square by 20 square. 20 square, that means 400. 12 square, 144 plus 256. 400 by 400, which gives me 1. So this way you have solved all the 4 problems. We'll do question number 11. All the sums will not do because the concept is same, and you can practice yourself, and if you don't find some difficulty, you will not learn it. So better few sums I am giving you clue, and rest of the sums you can do yourself. So in this sum I found I should show you, because cos A equal to 0.6 given, and you have to find all the other trigonometric ratios for the same angle A, cos A. So you have to find out A, you have to draw a triangle, and A should be some acute angle, for which it is given cos A equal to 0.6. That means 6 by 10. Let's mark the other points also of the triangle, and C is the right angle. So if you simplify this, 3 and 5. So this cos A equal to 3 by 5. So that means we know cos A is the ratio of the base to hypotenuse. But base is not 3. Base to hypotenuse, the ratio is 3:5. So we cannot write base is 3, but we can let CA equal to 3K. Some constant must be multiplied with the 3. And similarly, AB, let the AB equal to 5K. Now you have to find out sine of A, cos of A is given. So tan of A, cot of A, sec of A, and cosec of A. Now, without knowing this is 3k, this is 5k, but without knowing the third side, many of the ratios will not be able to find out. So let's find BC. BC square equal to BA square minus CA square. So 25k square minus 3k whole square, 9k square, which is 16k square. So BC will be equal to 4k. The square root of 16 is 4 and k square will give k. So sin A equal to perpendicular upon hypotenuse. So BC by BA, tan A equal to perpendicular by base, BC by CA, cot A just of reciprocal of tan, so CA by BC, sec A is reciprocal of cos, sec A you can find out 3 by 5, so sec A will be 5 by 3, and cosec A again reciprocal of sine, so BA by BC. Now you know BC is given, BC you have found out 4k, so 4k by 5k, which is 4 by 5, tan BC upon CA, 4k by 3k, that means 4 by 3, cot just reciprocal of tan, so 3 by 4, sec 5 by 3 already we found out, and cosec reciprocal of sine 5 by 4. So all the trigonometric ratios you have found out like this. Let's see this sum, question number 13. Given sin theta equal to P by Q. So theta is any angle. Suppose this ABC is one right triangle, B is 90 degree. So let angle ACB equal to theta. So this I can denote as theta. And given sin theta equal to P by Q, that means sin theta, we know sin theta equal to perpendicular upon hypotenuse, so AB by AC. So P by Q. So sin theta, AB, this is P and AQ is Q. Find cos theta plus sin theta in terms of P and Q. Fine. Cos theta, for cos theta we must find out BC because cos is base upon hypotenuse. So BC we have to find out. So BC square equal to AC square minus AB square. AC is Q square minus P square. So BC will be root over Q square minus P square. Children, this cannot be possible. This is not possible to find the square root of Q square minus P square. So we will keep like this only. So BC we found under root Q square minus P square. So cos theta, our sum is cos theta plus sin theta. Cos theta is BC by AC and sin theta is AB by AC. AC BC plus AB BC is root q square minus p square plus AB is p and AC is q. So this is cos theta plus sin theta in terms of p and q. This you can give the answer. Students, hope you have understood the trigonometric ratios, what I tried to explain you. We'll very soon meet with you with the next exercise in new videos. Thank you for watching. Bye bye and take care.